Right, Miller update. Removed the old motors and transformer unit today. New motors installed, all the brackets we quickly knocked together on in CAD, designed, made up, CNC machined, sort of machining of the week. Brackets all now in, so now we've gone from direct drive to belt drive. So basically I can put tension in there, there's no play in the coupling at all because I can pretty much dial the belt tension out, which is great. It's another thing to get rid of any possible backlash. So new motors should be over twice the power of the old ones. A new style of wiring, and then the old ones were 6-wire bipolar. 6-wire unipolar. These are 8-wire bipolar. Wired up in parallel for the moment. I'm going to try the parallel setup. If not, I can put them down to series. But I like the idea of running higher ampage that you can in the bipolar parallel. Right, so brackets in, and the machine. You can kind of see the bag. Had to machine also out to take the motor and the spigot. That's all in there. So now we're belt drive. I'm a lot happier actually. The downside now is I've got to build a swarf guard to cover up here. The bottom doesn't have to be completely enclosed, but I've got to at least try and cover up of here to stop any swarf getting into that. That's the Y. The X-axis was a little bit simpler in some respects. Would have liked to have turned the motor around the other way like I did with that one, reverse it, feed it in on itself, but unfortunately the X-axis goes all the way in. This part here is actually part of the Y bed, so basically this comes forward and back. That gets kind of in the way, so to bring a belt this way I could have easily just cut this piece out here off, but this piece here is actually part of the bedway and part of the corner drip tray for the back. Couldn't take that off, would have to get a ridiculous sized pulley to belt it either side. So I've gone down with the motor, so I would have liked to have gone back and had the motor pointing that way. It would have been kind of in the way of the thing as well, which is kind of a shame. Or at least had it round here pointing out at the same height. Just trying to make it a little bit easier for me to walk in and out through past the machine, to be honest, in some respects. But now I've got the belt drive in, so Y-axis is there. Got a little bit more. Could have just done with a little bit more clearance on the side here. I may have to take this plate off and just mill this back edge here on a manual mill. My friend's got one I can borrow for a little while. I relieve the top here. The full width is 152 and a half. I relieved it 145, but to be honest I didn't think that this port here would actually hit there, which unfortunately, if you don't there, it just kisses. Click. Which is a shame, so about 3mm over here would have missed it. As you see by that's the dead stop, and that's where it normally hits, so basically I'm losing about 2.5 inches, 3 inches of travel there. So I just need to skim that all the way down. But, I'll do that some other time. I don't need 32 inches in the Y and the X for the moment, so I want to get it on and running. So motor's in, belt drive's on, everything's nice. Okie dokie. I'm thinking actually about putting a frame up here. I'm kind of almost getting to the point now where I'm completely enclosing it like a normal CNC, putting a frame across the top here and then just draping down some clear plastic covers just to make it easier. So belts on, guards to make. We have a few extra toys to play with. This is the new transformer. This is 72 volt. The old one obviously was only 47. I'm going to put back in and reinstate the original main 30 amp, basically main on and off switch, but it is also a breaker. I'm going to reinstate that and bring that up here to the panel. So I've got to build a new panel here. The old transformer. There's this old girl here. So she's only 47 volt, which is fine for the old thing, but I really want to uprate it. Nice capacitor smoothing. But that's the old kind of big and hefty thing. Obviously everything shrinks these days, so now we've got this. So I'm going to wire that up to here, put some terminal rail in here, and rewire this. I've got a little 12 volt switch transformer coming, basically power supply unit that's coming. I need the 12 volt supply for the breakout board so that it can give me a 0 to 10 volt output to the VFD for the spindle speed. I've got a little 5 volt version of it in the machine at the moment. It's kind of untidy now. This little baby here, that's a 5 volt. It's going to get a 12 volt version of that to get into there. So that's the mill at the moment. Obviously I was machining all these parts last week. The end caps here, these I actually machined out as well. So these were machined with the old motors, but just very slowly, so I didn't get any lost steps, didn't get any lost movement. So machined these out there, obviously completely hollow. The inside they're just about 5mm thick all round, and I've put a mounting plate in the back there, which is what these two screws are here for a little junction terminal rail. And say presently there's 8 cables for here. I'm only connected by 4 because the geckos only take 4, but it's wired in bipolar parallel. There you go. I bored the pants off somebody. Okay, thanks very much. See you later.